Hello and welcome to the DCG development update. We are happy to share what the core, the mobile, and platform teams have been working on over the past 2 weeks. If you have any questions during the update, please post them in the live chat below. You can use a Q or a question prefix, and we will answer them in the Q&A session at the very end. So without further ado, let's jump and let's start with the platform team.
Yep. Okay. As an overview, the main thing that we were working up, actually, please share
Yeah,
if you can.
I should be able. Um, can you see it?
Yep.
Okay, 1 second, it's loading for me. So
Okay.
the
Here we go. Yep. We worked a lot on 2.2 things, also on DashPay. For me, it was actually only Rust Dash Core and iOS. But I was away for about a week of the two on holiday. Um, yeah. Paul worked on Dash Evo tool, Ivan on the JS SDK. Tender Dash was done by Lucas did a few things on Tender Dash and a few things on platform. So let's start by talking about the 2.1 rollout. We activated, there are no issues, and it was a success. Those are the three best bullet points that you can have, right? Nothing wrong. Everything worked fine. Great. On to 2.2. I can actually also say now the issue that we had in 2.0 and before, really quickly. We found an issue. I'm not going to go deep in the details, but there was actually a way to take down the network that we patched in 2.1.3. Um, Very hard to figure out. Like, I don't think anybody really could have actually figured it out, except, people working at DCG. In fact, I found it. But yeah, it was patched, no longer able to take down the network, um, and everything is golden. And I don't really think there are going to be many more like that. That was actually it was a one line fix needed, but and it had to do with if you were able to update there was just a small issue in operator identity of Evo nodes. So the way to actually create the issue was to create an Evo node, change the operator to somebody else, then change the operator back to the original operator. And when you change the operator back to the original operator, um, also change the node ID, I believe. It was a very, very specific set of events that you would have to do to stall chain the network. But it happened on testnet randomly. Well, not really randomly because we were testing things there. And then we immediately patched it in 2.1.3, and it will never hurt us on mainnet. Okay, excellent. Let's go on to the next slide.
Lucas?
Hi. Yeah, so I started with some tender dash. I will start with some tender dash maintenance. It was like minor improvements in some unit tests that were flaky, and some dependency updates. Nothing serious. Just a regular maintenance to have like current dependencies up to date. And these updates were merged into 1.6 dev, so it's not released yet. They will be part of the next release. So that's it on TenderDash side, and I've spent much more time on RSDAPI, and here I did a fix for an error message parsing. So when a developer was sending a state transition that failed, we didn't have correct handling of error messages. The result was that user was getting unknown error. This fix should improve developer experience in this area. Basically, that information was still available to the developer, but like it was hidden. Now it's more straightforward. As we have new RAS-DAPI, we have removed old one from next platform version. So in the dev version, we already don't have this DAPI. It's removed. And next thing is I think I also worked on that in previous sprint, but right now it's support for event subscriptions in platform. So the idea is that the platform itself can emit events, and that's where this PR finishes. It has, I think, 2 events already implemented, but it's just so some infrastructure to generate these events and deliver them to SDK. And now that it's in review right now, and next step is to just do the code that will fire these events. For example, when a user might want to get any information about any changes to documents containing some name, like John, for example, and he can subscribe to events like that. And then in the future, in separate PR, we'll create a feature that will just emit events when object matching this query, so containing this name, are modified or whatever the user requests. But this is just some infrastructure for this right now, and the logic to actually fire that event and emit that event and needs to be done in a separate PR. And another, it's quite small feature, but basically we didn't have a reliable way to check what will be the next epoch. So right now the get status endpoint reports information that what will be the protocol version in next epoch, so we can more reliably verify if the new protocol version will activate in the next epoch or not. So that's it in terms of RSDAPI. On the next slide, I also did a few, also not so big changes or fixes in other parts of platform. There was an issue that when a transaction fails, identity nonce that is cached locally was not reflecting the failure. So developers sent a state transition to change something in the platform, but it failed. So it wasn't executed, so that identity nonce was not increased, but SDK assumed it was increased. Right now, we just remove that from cache so that in case of error, we will just query platform again to get correct nonce. And 2 improvements in terms of dashmate and deployment tools. First one is to use separate ports for mainnet and testnet. It was merged. Second is improvement on how we can connect Prometheus to services. So Right now, when you start local node, you can also start Prometheus there, and it will automatically load all metrics from that node, or using Docker labels that are defined there. So basically, if you want to see if your master node is working correctly or monitor performance or whatever, it should be quite much easier than previously to configure that. And to like release oriented and like workflow oriented features. So first one is some script to help AI install all dependencies and do the coding tasks. It's basically a script for Ubuntu to install some dependencies, install protobuf generator that is needed, Rust, Node.js, all that stuff. All it's based on Docker files we have. And second thing is to just not have version tag in every crate, which we have, I think, multiple crates in the monorepo. Right now, all these crates, wherever appropriate, use centralized cargo toml file for the whole project, not individual crate level crates, configuration for versions. So that's also a minor improvement in how we work, how we release the platform. And I think that's it on my side.
Thanks, Lukasz. I'm excited for the event subscription stuff to come out. I think there are some cool things will be able to do with that. And actually, one of them, I think, like one of the reasons, like we kind of thought to. I mean, I know Sam had this idea for a long time, but something that kind of said, "Oh, we should do this now," is because we were planning to start like releasing Dash Evo tool as a signed binary for Mac, and like we were thinking it would be cool if we can like emit some document on platform, and then for example some DCG devs can like they'll get a notification that this document is like indicating, okay, there's a release of Dash Evo tool that we need to sign, and some DCG devs will get this notification that it's ready, and we can basically sign it that way. So I think that'll be a cool feature, and that's like one thing you can do with it. Yeah, and I have some other ideas as well. But yeah, thank you. I was off last week, so don't have a big update. My mom and sister came to visit me in Asia, and we did a little tour of Vietnam and Thailand. But I'm back now, and so in Dash Evo tool, basically worked on like implementing more stuff related to SPV. I took a lot of the stuff that we had done on iOS, for example, transaction history from SPV sync. We added that into Dash Evo tool. Some other small features like you can view your wallet's private keys now and send funds from your wallet from Dash Evo tool, although it doesn't go through SPV yet. It's because the Dash Evo tool wallet is like watch only addresses and stuff. But we're basically looking at making it a more robust wallet within the next probably this sprint. But the general wiring is there. I added wallet accounts, like same like we have on iOS, basically like identity registration accounts, main account, top up accounts, some proposal owner account and stuff. Yeah, and I'm basically trying to get some things working and get ready for kind of overhauling the wallet or migrating the wallet. Yeah, and I'll just share my screen quickly to show the. Oh, I can't share. Oh, Balash, could you let me share? Thank you. I'll just share quickly so you can see. I'm gonna make it look nicer. I'm not focusing on how it looks right now, but yeah, like you can. So here I have wallet. I just named it A loaded, and this was I synced this before. You have all your transactions now confirmed at. This is the block height platform block height, or is it platform block height? And all your accounts, identity registration and stuff. So when you sync, like this will all auto populate, and then these kind of act like filters for right now. For these are the addresses associated with each account. So yeah, I think as Sam had mentioned before, this wallet screen needed some love, and yeah, we're trying to give it that love now. So yeah, that's all.
Thanks, Paul. Balash, can you reshare the
Yeah, I'm on it.
cool.
I don't know why it's loading too slow. Anyway, let's continue with roadmap and strategy.
Yep, that one's mine. Roadmap and strategy time. Yes, so a lot of people have been talking about hiring, and what we're doing in terms of hiring. So the plan there is to hire back smartly, not too quickly. We really want developers who can really make a difference, and we're not just filling roles to fill roles. So, for example, we just made an offer to an iOS developer, they accepted, but to get him, we actually went through 90 CVs that we actually wrote down, and we got probably I just realized that only like 2/3 of resumes we even put in the spreadsheet because some were so bad, right? But 2/3 of okay enough resumes we put in our spreadsheet. We probably interviewed, I don't know, Brian, how many candidates would you say we were interviewed? Like 12, 14?
Least, yeah. I mean, I think more than that, but
It was a lot. So we hired somebody there. We also hired Dustin Face, a lot easier. He had let me know about a year ago that he was looking for work, and then I was just like, I wonder if Dustin Face is still looking for work. So I contacted him, and yep, he wanted to come back. So we rehired him as well. As I was saying earlier, yeah, like experience shows that a bad hire can actually slow you down. So like I actually would prefer to take a lot of time trying to find these really good candidates than just taking people and then seeing. A lot of the time that slowed me down, and I don't like spending 5, 6 hours explaining something to somebody and then doing that again like once a week and then 3 weeks later having to fire them. It just is such a waste of time. So we only really hire yeah. Ivan is probably back as an official rehire. That was something that I'd written down, and I had not yet got the confirmation, and I was planning on figuring out if that's true or not. So strike that out for now. We're hopefully it will be true. Pavle is the person who was hired for iOS. He'll start on November 24th. By the way, Ivan has been working for us for 2 months, but we were not sure if he would stay on. We're still working that out. So the goal here is to hire 2 additional developers. One iOS Android developer to be decided, and 1 platform SDK developer. And I'm going to talk a little bit about the SDKs in the next slide. Yeah, and if you guys hear my beautiful voice, this is the sound of a man who has a very bad throat pain. But it gives me a very deep voice, so I like it. Okay, so people have asked about this quite a lot, and I kind of wanted to explain what our SDK roadmap it looks like. So we built out the Rust SDK, which and the Wasm SDK and the Rust SDK FFI, which is basically C. And our Wasm SDK and our JS SDK was shipped in 2.1. We're still making modifications. There are going to be good modifications coming out in 2.2, especially surrounding identities. No, I'm not identities. It's like entities, sorry. So the entities will be more mapped out and make developer experience a lot better. That's what Ivan's been working on for the last few weeks, and he's actually been working on integration, helping some community developers integrate the JS SDK to make sure everything's working. And we're also learning from experience, like what problems people are having. So we're going to be making that better as time goes on. Yeah, so what SDKs are in the pipework? So we have the iOS SDK in Swift. That will be released in 2.2, pretty much next month, or it's stated to be. The Android SDK will be a follower earlier next year. With those 2, we can combine them into a React Native SDK is probably the way we'll go with that, and create a React Native SDK for spring 2026. Then these are more long-term goals, but we also plan on having a Python SDK and potentially a Go SDK. I wrote Go because that was kind of part of the plan. However, yet not 100% sure. We go with Go. We might go instead with C# or another language, even though when I say C#, I want to throw up. And I actually do because I'm sick. Okay. Actually, C# is an okay language. I don't know why I feel that way. Okay, so roadmap. We kept this roadmap. I just want to reiterate it from time to time. We're still targeting 2.2 in December, with the UTXO system, stream notifications, and the iOS SDK. 2.3. This is the same slides as 2 weeks ago. I just prefer to keep them in everybody's mind. 2.3 will be next slide, please. Yeah, it will be the token marketplace. Really hoping to get that about 2 months later as well. And then 2.4 will be state sync. And that's all I really want to talk about for platform. So let's go on to the mobile team.
Sure, thank you. So on Android, we had a few more things that we had to take care of for supporting Android 15. That ran into some other issues that we're dealing with as well. But we did finish the transaction metadata. So that's going to be in our next release as well. So that's the biggest, I'd say, major feature that's going to be released, allowing our users to save their transaction metadata like prices, gift card details, other kind of transaction info that we store locally. It won't get lost anymore when you restore your wallet to a different device. It can be pulled from platform. That's also great for other projects that might want to, use the Dash network for a similar feature in other wallets. So not, just for Dash Pay really. We did have some issues still working on relating to heavy CoinJoin wallets on the sync process and some contact issues. That's also planned for the next release. And then just some, well, it turned out to be some, or started out to be some minor changes for CTX network updates. But at least the initial version we're looking to get out in our next release as well. And then the dual usernames, it's still in testing, but paused to kind of take care of some of those other priorities first to get that 11.5 release out for Android. On iOS, we did our first kind of, I'd say, full round of testing of that example app for the Rush Dash Pay. So I call that kind of phase one. We did identify a few different issues that needed to be fixed. So we're just kind of in our testing rounds here. Another issue was partially fixed relating to the CoinJoin derivation path for the Rust Dash Pay, and for the regular Dash wallet, we do have a few bug fixes and feature or improvements to the UI. Just kind of on hold. All the development is pretty much done. We're just waiting to get unblocked from the App Store, and that will all be in 8.4.3. That's all I have for mobile.
Oh,
Okay.
okay. I forgot to do most of the slide. So what I've done on DashPay, it's mostly been work on Rust Dash Core with so Dustin Faze came on board this Monday. Since then, I've been talking with him a little bit of how we're going to do stuff. But in terms of what I did is I exposed all the filters so we can now view all filters in iOS. Which basically allows us to debug directly on the iOS app why certain filter matches are not happening, which is currently what I'm working on. I also worked intensely on the platform wallet. Before so how it worked before was basically that we had as a block would come in, you would check all the transactions for a match in the associated wallet. That was also done as sync code. I switched it completely up. I switched it to async. I extended it in the platform wallet. So now when a acid lock transaction comes in, it will match the acid lock to the identity that it created, and it will automatically download all your contacts, your contact requests, and then continue the sync of the wallet. That's where I'm at right now. There are bugs, and but it's all been made async and it's all compiling. It just doesn't yet work. Now, I've only been spending about, I would say, 3 days on this since the last sprint review. So it's not as if I was working on this for 10 days. I only worked about 5 days of the last 10 days. The others, I was on a safari. And during that safari, the price of Dash went up. So, yep. KL's belief that me taking time off increases the Dash price has continued to be proven true. But yeah. But now I'm back home. So I really just want to get this out of, like, I want to get iOS done. We have the next hire coming on the 24th. I want to get almost everything like I want the system working properly by the time he arrives. And there's just been a lot of progress. There's probably been like 6,000 lines progress in the last few days. There's a lot going on. I just don't have anything to show yet because it just doesn't yet work. I'm like narrowing down these little issues. So hopefully in 2 weeks we'll see a better picture.
Awesome. Well, thanks, guys. So
Yep.
I'm actually pretty excited about a number of things to talk about. First thing, of course, we released V23 very recently. I believe this Monday V23 was out. As of last night, I updated these slides, and 23 adoption is up at 13% so far. Just for people who may not be aware, right, the way that the Dash network works is there is a proof of service system, and that system, one of the things that it does is it will check that you are running the latest version. So once somewhere around 75 to 80% of masternodes have upgraded to V23, once that point is hit, if you have not upgraded, you may get a proof of service ban. You likely will get a proof of service ban. So we're nowhere close to that yet. Last night we were at 13%. This morning we're around 14%. So you don't have to worry about that yet, but just keep that in mind. You do want to be, upgrading relatively promptly, just so that you make sure that you don't get any kind of an issue. All right. So, like I said, V23 was done. That's very exciting. There are a couple of small things that we found that we may release a 23.0.1 for in the near future. Nothing super crazy. Extended addresses as well as like hardware wallet backed wallet stuff is still in progress or in review. So and then the biggest thing that I'm going to talk about today is a relatively big set of development and work that I've been focusing on around instance end performance and instance end latency. It applies to other aspects of the like LLMQ signing process, but I haven't really. I've primarily been focused on the instance end side of things. So I've been doing, if people have been looking at testnet, I've been doing a lot of testing on testnet recently and debugging and deploying new versions and figuring out what works and what doesn't and what's valuable and what's not. And I have some really cool things to share. So, yeah, we can move to the next slide here. So the first thing that I want to talk about was raw performance investigation. So this is a little small. I'm sorry about that. I can share the images in more detail if anyone wants them or on Discord or something. But this was basically the first thing that I looked at. I was looking at kind of performance bottlenecks that we were seeing and trying to figure out how to improve them. So on the right side, what you see is they kind of look as one image. They're two separate images, top and bottom. So the top is before my changes, or before the recent changes, and the bottom is after the recent changes. Both of these sets were about 20 transactions per second. And then there's a box, average instance unlock delay. So this is measuring the amount of time that it took from when we saw the transaction to when we saw the instance unlock. So you can kind of see the top one, it ebbs and flows a lot. It goes up a lot, it goes down a lot. It bounces around depending on what's happening. It seems like there was some performance regressions almost around when blocks happened, primarily because on testnet, every member is in basically every quorum. And so when blocks happen, there's chain lock signing and all of that kind of stuff that also happens. And so there's more work that is happening right when a block happens. So it's not surprising to see a performance degradation around that. But you'll see when we were doing 20 transactions per second, there were times where instance end was able to push 30, even 40 for a brief moment, instance unlocks per second. That's the green line. So the yellow line here in that box is the transactions per second. The green line is how instance end performed relative to it. And so you can see there were some times where instance unlock performance was down close to 1 or 2 per second. And so performance was really degraded during that time period. There were other time periods where it was, humming at 40 per second, right? So kind of ebbed and flowed. There were some inconsistencies and there were some kind of issues. And 20 transactions per second on kind of before these recent changes was kind of the best that we were able to push it to without seeing, even at 20 transactions per second. If you look at the far top right box, you can see the average duration that it took in various metrics. And so during this whole time, the average low was something like 90 seconds, which is definitely not acceptable for instance end, right? We generally want to see sub 2 seconds, so 90 seconds is definitely not good. And the average, like the average middle 90%, so getting rid of the top 5 and bottom 5%, so just looking at kind of the middle bit block, the average of that was 185 seconds, right? So really not acceptable. We had some all the way up around like 1,000 seconds, right? So not cool whatsoever. Um, After these performance optimizations, which there were a number of them, but it was all focused around, just making things more optimized and doing the same work more efficiently. So a lot of that was reducing mutex contention in networking code. That was one of our biggest bottlenecks that we were seeing. Instance End does a lot of networking. It sends a lot of messages. And there were a couple of changes that needed to be done to kind of change which data structures internally we were using for different types of relaying to use less contended mutexes. And then there were other changes to mutexes that we needed done. As an example, Bitcoin never uses shared mutexes. In computer science, a shared mutex is something that you can either take a read lock to or a write lock. And so when you're changing something, you would take a write lock or an exclusive lock. And when you're only reading it, you can just take a read lock. And so you could have 10 readers at one time and only ever one writer, right? Because reading is safe to do in concurrency. So Bitcoin never implemented read-write locks or shared locks for whatever reason. They didn't see a benefit to, they didn't have this level of network traffic. For us, it was actually really important. We have a couple of networking data structures that were very, very heavily contended. But as you can imagine, 90, 95, 99% of the time they were being read from, and they were really only being mutated when we added or removed peers, which doesn't happen all that often. So converting some of the mutexes like that to shared mutexes significantly reduced our mutex contention. One of the big reasons why mutex contention is a big deal is when a thread runs into contention, you might see like a complete context switch. The CPU might switch to a completely different thread to let that thread kind of, get to a point where it can continue, where the mutex is free. And anytime you have a context switch, it's super expensive. It's a lot of thrashing on the CPU. You're going to have a lot of cache misses. Like, it's just very expensive anytime you have a context switch. And so the more that you can do to minimize the time in contention, but also minimize the number of contentions in general is really, really important. So as an example, moving to stuff like a shared mutex, the number of contentions that we were seeing on one of our data structures literally reduced by 100%. It became completely non-contended. We never saw contentions on that mutex. One of the other mutexes, we basically have two critical mutexes for networking code. One of the other ones reduced by over 50%. On that one that reduced over 50%, an interesting byproduct that we saw is when it did contend, it contended for longer. But because there were so many fewer contentions, it was still a very significant performance improvement. One of the other things that I found was there was a spot where we were doing BLS aggregation and verification on that aggregation. And the way that we were doing the aggregation was just slower. We were basically doing a loop over all of the signatures and aggregating them one by one. The library that we use supports aggregating a bunch at one time, and so you can just give it like a vector or a span or a view of some number of them, and it'll just aggregate all of them. For whatever reason, when this code was written, we didn't use that syntax. Maybe that kind of syntax was added later, but it was significantly more performant to just do it all in one batch instead of doing it iteratively. That improved our BLS aggregation performance by about 10%. And at these like 20 transactions per second level, we were basically hitting the point where the testnet nodes that we were running were basically CPU bound. So we were no longer like network limited or just like algorithm limited, but we were just pure compute limited. So something like this 10% actually was a like significant and valuable improvement. And so what we can see is if you compare on the right side the top and the bottom like halves, significant improvements. So just looking at like the top right box, the transactions per second and IS lock averages box, ignore the like 9.7 versus 19.3. Both of these tests were around 20 transactions per second. but the top one, I basically extended the tail end on to see the instance unlocks recover. And that resulted in the average being pulled down. But both of them, in effect, were done at 20 transactions per second. You can see the top one, right? Our average minimum was 90 seconds. That doesn't mean our absolute minimum was 90 seconds. We definitely had a lot quicker than that. But over the entire span of the test, the average 10-second minimum was 90 seconds. The bottom one, 283 milliseconds, right? That is a huge, huge change. And same with, our averages overall at 20 transactions per second, we were seeing 1.6. Before we were seeing 185 seconds, right? And part of this is that, Instance N was getting so overloaded that it was kind of just falling behind and things would just take forever. And so, right, in the kind of optimized flow, things were able to keep up. And so at 20 transactions per second on testnet, we were seeing 1.6 to 1.8 second averages. And even the upper 90 percentile range, which is generally like what I really kind of look for, we're always going to have some that are super slow, especially on this test, because on our testnet environment, we have like 50 nodes that are just running core, and I can kind of update those as much as I need to do testing. We have 30 of them that are running platform in our, Evo nodes, and I can't really touch those without, dealing with Sam, and, he's a pain to deal with sometimes, and he gets cranky. So, if I can do stuff on my own, I try to prefer that. So, I didn't push this like updated fixes to every single node, so maybe some of the extremes could actually be brought down even better. But we were seeing, upper 90 percentile going from 300 seconds to 3 seconds. So that's already, right, this is a huge gain at 20 transactions per second. So very, very cool about this, but I wasn't necessarily satisfied. So we're going to continue on, and I'm going to explain something a little bit more complicated to a degree, but I think it'll be interesting. So yeah, next slide here. All right, so if we look at this image in the bottom right, you can kind of see how recovered signatures are currently propagated throughout the network. You can see if you look at 1 and you follow like the pointers, you can see 1 points to 3 and 1 points to 5, right? So you kind of have some number of nodes, but you don't propagate to everyone. You kind of propagate to, like 1 plus 2 and plus like 4 and plus 8, depending on what the exact like network parameters are. But it kind of creates this like ring topology where stuff gets propagated relatively quickly. But if we kind of run out the math and what this looks like on a 60-member node, what you see is it takes about 6 hops for everyone in the quorum to become aware of something. That's fine. But there are actually kind of 2 problems with this. Well, so how do I want to explain this? So yeah, so right, this creates a situation where 1 sends to 2 and then 2 sends to 6, right? So 6, to get to 6, it takes 2 hops, right? And so if we look at the mainnet quorum and how many hops it takes for the entire quorum to kind of become aware of it, we see that it takes around 5 to 6 hops for everyone to become aware of it. It basically takes 5 hops for like 80, 90% to become aware of it, and 6 hops for everyone to become aware of it. So this isn't ideal. If we look at mainnet and think about what our expected network latency is, we have somewhere around half to 2/3 of nodes are Europe-based, maybe a third-ish are based in North America, and the remainder are based in Asia, basically, right? And there's very few in like South America or Africa. That's kind of what the network topology looks like. If we kind of run some assumptions of what data center connection speeds look like, if you average out all of the connections that everyone is doing to each other, we think that that would be somewhere around 80 to 100 milliseconds on average of round trip latency. So at the bottom, this is what I'm calling RTT. But if we just look at the algorithm of how recovered signatures kind of propagate throughout the network, I'm going to start at the top. So I have this to represent, this is how many hops it takes for the quorum to see the transaction. Every masternode is connected to about like 8 others. And so we can kind of estimate that it'll maybe take around 3 hops for most people to see that transaction. Then everyone does the signing for round 1 on that, on the inputs of that transaction. And so they send that to one member. That one member creates a recovered signature and then propagates it to all of the members of the quorum via this ring algorithm that I described. So that's going to take around 5 hops. And then the second quorum is going to create a recovered signature. They're all going to send to one member. And then that member will create the recovered signature and again propagate it to the network. And so in this case, we're assuming about 6 hops to propagate to the network. With that, we're able to create this formula, this T-total formula. I don't actually know why I have it written down twice here, but this formula basically describes how long we think instant send should take based on network latency. This is a little optimistic. It doesn't really have any constant terms in it, right? We can think that like there's some amount of stuff where it's just going to take time to do signing and do recovery and that kind of thing. But so this is maybe a little rosy, but for the most part, this is a relatively good approximation. And when we take our observed performance on mainnet, we see about instant sends happening in about 1.9 seconds. If we plug this back into our formula, we can calculate a round trip time based on the performance that we observe of around 83 milliseconds for average connections between masternodes. And like I talked about earlier, with like the distribution that we have, we expect somewhere between like 80 to 100. This fits perfectly into what we expect. If we look at something like testnet and we plug in, testnet is a much more consolidated network. Pretty much everything is kind of ran on, one data center in EC2. That's the average. So we can kind of say the average is going to be a lot shorter. It's going to be realistically the actual network latency is probably 10 to 20. But if you add in some of the jitter that we have in kind of our networking sending code, realistic performance, realistic round trip latency is around 40 seconds. And our formula for that predicts testnet will see about, 0.9 seconds. And guess what? That's exactly what we see on testnet is about 0.9 seconds. So this formula isn't perfect, but it's a pretty good approximation for what we expect instant send performance to look like. So now with this, I'm going to model out what the expected performance gain should be with a couple of modifications to our current kind of instant send algorithm. So we can move to the next slide, and I'll talk about what those changes to like the instant send process look like. So sadly, I don't have an image for this one, but ever since gosh, I don't remember when it was. But for quite a long time now, instant send has used what's called concentrated recovery. And what this means is every single member of the instant send quorum is connected to every other single member. And right now, we only use these connections basically for signature shares, but there's no reason why we should only use them for signature shares. We can also use them for the recovered signature so that we don't have so many hops. And then there's one more kind of optimization that we can do. Right now, we use the inventory system for basically telling people, hey, we have a recovered signature. Let me know if you're interested. This results in people actually learning about the recovered signature in about 1.5 times the round trip latency, right? Because we send out an inventory, we say, here's a hash, you might be interested in it. So that's half of a time. That's half of a round trip. Someone else says, yes, I would like that. That's another half of a round trip. And then we send it. So that's 1.5 round trips in total. This isn't actually what we need to be doing because in concentrated recovery, we know with pretty good certainty that we are probably the only person who actually recovered this signature. In some cases, there might be 2 or 3 that race at the same time and they all might create the same recovered signature. But the way that concentrated recovery works is we first send to one node, we wait a couple of seconds for a recovered signature to appear, and if it doesn't appear, then we send to a second node, right? And so in 90 to 95 to 99% of cases, only one person is going to ever recover the recovered signature. And because of that, we don't need to use this inventory system to propagate it. We can use like a proactive relay system where as soon as we recover it, we send it out. So we don't send out a hey, let me know if you're interested in this. We just broadcast it wide for basically all of the masternodes that we're connected to see. It's a little bit more complicated than that as to which masternodes are involved. But basically, the way that it would now work is every instance end quorum, whenever there is a recovered signature that is generated, that member will immediately broadcast it out to all of its peers in that quorum, which is every other member of that quorum, as well as all of the watch connections, which connect that connect different quorums together. So one member will recover that signature and he'll immediately send it out to all of his members in the same quorum, as well as basically 23 people in all of the other quorums. And then that person in the other quorum will relay it through inventory and send it out to all of the other people that need to know about it. So this is similar text as to the previous one. It's slightly more complicated because it describes some of the new nuance of the differences of when we send out via inventory and when we don't send out via inventory. But basically, with this change, actually, Balash, can you go to the last slide for 1 sec? The previous slide prior. So here, God dang it, I didn't. So basically, if we add up the 3, 5, and the 6, this is 11 plus, so 14, 5, 6, 7, 8. So like it's like 18 and a half round trips is what we expect our like performance to be, is like 18 and a half times what the network latency is. So continue to the next slide. So 18 and a half. This algorithm gets us down to about 10 and a half. So we can run this new math and we can see that's about 8 round trip times the 8 RTTs of gain between the two algorithms. And so with that, we can look at testnet and say, okay, on testnet, we should see a like new performance somewhere around like 400 milliseconds. On mainnet, we would see a new performance somewhere around like 900 milliseconds. But the difference between the two is more so what I'm going to look at, because there are some like constant factors that this algorithm doesn't take into account. But the difference that we should expect is somewhere around maybe 400 milliseconds on testnet. And on mainnet, we could expect to see a difference of around like 600 to 800 milliseconds of gain from the like older algorithm to the new algorithm. So last night into this morning, I deployed a version that implements this algorithm onto testnet or onto the majority of the nodes on testnet. And this is what we saw. So I'm going to look at the bottom first. And on the bottom, we saw the average latency go from 1041 down to 771. So that gives us about 250 milliseconds of gain, a little bit more than that. So it's a little bit less than what like our formula estimated of like the 300 to 400 milliseconds. We were actually observing somewhere around 250 milliseconds of gain. But if we look at the top where this is at 20 transactions per second, this is when the network is under load. Here we see significant improvements, more significant than kind of we expected. So here we saw the average latency go from 2.3 seconds all the way down to 1.1. So this at load roughly halved the network latency. So kind of with all of that, with what we observed on testnet with this, deploying this onto mainnet, my guess is, based on the kind of formulas that we had and then what that formula predicted and then what we actually observed, the formula predicted that we could go from 1.9 to about 1 second of latency on mainnet, right? So the formula predicted we could get down to around 1 second. Based on this, I think it's probably closer to 1.3 to 1.4 seconds. So that's kind of what I'm expecting if we deploy this out to mainnet. I'm expecting we could shave about 600 milliseconds off, going from 2 seconds down to 1.4-ish. We'll have to kind of, hopefully these changes can get merged in to develop and mainline, and we'll get this released as 23.1 at some point, and we'll be able to actually see what it shows on mainnet. Obviously mainnet is a much more diverse environment. There's going to be more kind of extremes. You might have some cases that are, very quick. You might have some cases that are slower. But one of the really cool things is looking at the tail of this, right? Both of these systems, looking at the top images here, both of these are very well optimized. All of them have all of the optimizations I talked about earlier. The only thing that is different is the algorithmic changes and how we propagate them. And if we look at the tail, if we look at the upper extremes, we can see the upper 90 percentile went from 5.5 seconds down to 1.8. And that's huge. That is a huge gain on the upper percentiles. And our high ends go from like 15 to 20 seconds to consistently right around 4 seconds. Our highest that we saw was around 6 seconds. And that is just a very, very significant change because one of the things with instance end is as you fall more behind, more load is happening at the same time. And so the more that you can do stuff really quick, the less you have to worry about at one time, and that makes everything faster. So there are some other changes that I looked at that may also shave a couple hundred milliseconds off that I don't include in some of these examples here. But and there's maybe a way that we can extend the proactive sending to not just be the first hop, but like the first and the second hop. We might be able to do that intelligently, but when I tried to implement it, it was annoying and I couldn't figure it out yesterday. So I got this first hop working well, but if we could get that first and second hop doing proactively sending, that could save us another 100 milliseconds or so of latency. So yeah, very cool stuff. I definitely kind of nerded out on some of this stuff and spent a good bit of time on it. But I was very excited to see this morning when I ran some of these tests on testnet to see the improvements that we actually had. I was very worried that I was going to do all this work and then there wasn't going to be a measurable difference. But especially under load, this created a very significant difference. So very excited to get this in review now and get the PR updated with all this new data and get it merged in. Awesome. So backport progress, not a ton to report here. V24 is pretty much wrapped up and V25 is basically what is in mainline progress. Yeah, nothing really to say there. Moving on to the next slide. You can see the list of PRs merged in here. So a lot of these are related to kind of some optimizations in the either instance end or networking process. So like 6905 on the right side was what I talked about with optimizing public key aggregation in our batch verification. 6912 was what I was talking about with using a shared mutex in some of our networking code. There are a number of other PRs here that kind of just like minimize the time that we spend in contended areas and that kind of stuff. But yeah, very cool. And I think we can move on to the next slide, which should be questions.
All
Okay.
right. Thank you. Do you want to take over, Sam? We only have one question.
I mean, I can answer that one. I'll say it and then I'll answer it. Could you please share more details on what specific platform side conditions or failures can increase an EvoNode's proof of service score, and by how much in each case? So there's nothing is the answer there. Platform does not increase the proof of service score currently. So nothing on platform will cause an EvoNode's proof of service score to go up unless you have a severely underpowered node where you're sharing resources between everybody and everything is very, very underpowered, in which case, if there's a spike in requirements on platform, it's possible that the core side doesn't get enough CPU. But in general, platform uses less CPU than core. So
yeah, I think the impetus of this question or the cause of it was in V23, we deployed a new peer-to-peer message that allows in the future platform to produce a message that is signed by a platform quorum. And once that message is signed and propagated, it would result in nodes being banned on the core side of things. But like Sam said, platform hasn't implemented anything to do that yet. It is just building the groundworks so that platform could do that, if that is so desired, which I believe it was requested, but we'll see if that is still
Yeah.
prioritized.
Well, we're hiring, so hopefully we'll be able to do a lot of these things in the backlog soon.
All right. Anything else before we wrap up?
Let's give 10 seconds for questions, and then if nothing comes, that'll be it. I guess that's it. I
All
will
right.
wrap
Thank you
things
very
up.
much.
Yeah, we'll wrap things up by just telling everybody all the animals I saw last week. I saw a lion, a leopard, a cheetah, a rhino, an elephant, Timon and Pumbaa, wildebeests, gazelles, hippos. The hippos were scary. Oh wow, there are a lot more I just can't think of right now.
Antelope?
Oh yeah, there were antelopes. I saw a leopard eat a gazelle and take its limp body up a tree and start eating it. I saw a herd. So I didn't actually know this, but lions, there's only one male lion, and then, well, there's a whole story behind how lions' social structure works, but I saw like 6 different lionesses tear up a zebra. That was interesting. Anyways, very, very, very interesting. I suggest everybody goes and does a safari once in their life.
All right. Thanks for being here, for the questions, the comments, and see you in